Okay, in this video, we'll be factoring out a constant before we factor the quadratic. So if there's a leading coefficient that will factor out, we'll move it out to the front and factor what's left, the remaining quadratic. Okay, so looking at this first problem, we have 3u squared plus 42u plus 72. Okay, so question is, it says if there's a lead coefficient that will factor out. So here's the 3. So that's what we're going to try to use on this. We're going to try to factor out that 3 and see what's left. And when I factor it out, what I'm really doing is dividing it from each term so that we can put it out front. Okay, so when I'm dividing it, which is factoring it, I'll put that 3 out front. And what's left is each one of these terms that are divided by 3. Okay, so if we divide this one by 3, those two 3's cancel out. You're left with a u squared. Okay, 42 divided by 3, that's going to be 14u, so plus 14u. And then 72 divided by 3 will be 24. Okay, so it did factor out. Now, if you try to do this and it doesn't divide in evenly into these numbers and it leaves you with a fraction, then you either did it wrong or it can't be factored. Okay, so it should look like this once you're done. You take out that number and what's left is all whole numbers. Okay, now we need to factor, so we need to look for two numbers that multiply to get 24. We're ignoring the 3. Two numbers that multiply to get 24 but add to get 14. Okay, so they're all going to be positive because everything's positive. So 1 and 24 doesn't work. 2 and 12, that one works. 2 times 12 is 24. 2 plus 12 is 14. So when we factor this, and we do have to keep that 3 around, it'll factor into u plus 2. That's the 2 factor here. And then u plus 12. And that's it on that one. Okay, let's take a look at this one. So we've got a 4u squared minus 24u minus 64. So we're going to try to factor out that 4. So I'm dividing each term. I'll put the 4 out front. Okay. So the first one, the 4's cancel. We're left with u squared. Let's see. Negative 24 divided by 4 is negative 6. And then we'll put the u there. And then negative 64 divided by 4 is negative 16. Okay, so we're looking for two numbers that multiply to get negative 16 that add up to get this middle number of negative 6. Okay, so remember, to multiply to get a negative number, one has to be negative, one has to be positive. If they're both negative and you multiply them, it'll turn positive. Okay, so it's got to be one negative and one positive. So let's do 1 and 16. I'll write it in two different ways, where the 1's negative or the 16's negative. Neither one of those is going to work because it adds up to positive 15 and negative 15, and we want it to add up to negative 6u. So let's try 2 and 8 would be the next choice. Okay, does either one of those add up to get a negative 6? Yes, it does. That one right there. Negative 8 plus 2 is negative 6, and if you multiply these two, you get negative 16. So this factors into 4 times u plus 2, and then u minus 8. Okay, let's take a look at the next problem here. This time we got a 5 that's sitting out front, so I'm going to try to factor out a 5. That means I'm going to divide each term and then put the 5 out front. Okay, so here's the 5 out front. Okay, the 5's go away, so here's the y squared. Negative 45 divided by 5 is negative 9. I'll put the y there. And then 70 divided by 5, that'll be 14. Okay, so we've divided out and factored out the 5 here. Okay, so we're looking for two numbers that multiply to get 14 that add to get negative 9. So we're multiplying to get a positive number, but we're adding to get a negative number. So we need both of our numbers to be negative. Negative times a negative will be a positive. Negative plus a negative will be a negative. So we're looking for negative factors. Let's do 1 and 14. That doesn't work. That gives us negative 15. How about negative 2 and negative 7? That one seems to work, right? Add those up, you get the negative 9. Multiply them, you get the positive 14. So this factors into 5 times y minus 2, y minus 7. Okay, let's take a look at the next one. We're going to divide out a 5. That's the leading coefficient. We'll factor out that, put it out front. Okay, so this gives us y squared plus 8y minus 10. Okay, so we're looking for two factors that multiply to get negative 10, that add to get 8. Multiply to get negative 10, so that means they have to be opposite signs. Each factor adds to get 8. Okay, so 1 and 10. Let's see, two different ways of doing that. This gives us negative 9, or 9. This gives us negative 9. Let's do 2 and 5. Okay, so 2 and 5, 2 and 5. Okay, make that negative and then make that one negative. Does anything else, any other factors of 10? Because it doesn't look like any of these work. This, you add them up, you get 9. This, you get negative 9. This, you get 3. This one, you get negative 3. None of those are adding up to the middle number. So we're going to say that this is as much as we can do on this particular problem. Okay. All right, let's go to the next one. So we divide it by 5 again. Okay, so that would give me 5 out front, and then we have w squared minus 3w minus 10. Okay, so divide each one of those terms by 5. All right, now we're looking for factors of negative 10 that add up to get negative 3. Luckily, we already have that work right here, right? Okay, so which one of those factors adds up to get negative 3? It's this one right here, 2 and negative 5. Okay, 2 times negative 5 gives us negative 10. If we add them up, we get negative 3. So this factors into, here's the 5, w plus 2, and w minus 5. Okay, one more. And this one we're going to divide by a 2. Okay, so I'll factor out that 2. That'll leave us x squared plus 12x plus 21. Okay, so we're looking for factors that multiply to get 21 and add to get 12. So since we're both multiplying and adding to get positive numbers, then everything's going to be positive. So we've got 1 and 21. That obviously doesn't work. That gives us 22. We've got 3 and 7. 3 and 7. That multiplies to get negative, or get 21, but it adds up to be 10. And there are no other factors that multiply to get 21. So 3 and 7 are the prime factorization of 21, so you can't go any farther. So we're going to again say that this is as far as we can go on factoring this problem. And that's it.